Hey everybody, today we are going to try and change up our code, make it a little bit better by using some math with variables. And we are also going to learn how to make our own function to clean up our code a little bit. Before we do that, what we should do is make a copy of our circuit so we can start coding it up without losing what we've done before. And you can do that by clicking on the little gear here on Tinkercad, and then going on to duplicate, and then we get a second circuit, or we should at least. There we go. There's a copy of the thing. And so we're going to keep the circuit the same right now. We'll change it up next video by adding a little bit of more hardware to make it more interesting. So let's go into coding right here. And what we're going to do is, you see before here we have our time variables here. We've got quarter and quarter. You probably put in some more, like say half note, which in this case would be 400 milliseconds long, and you might have even put in a dotted half, which would be 600. Why did that happen? It's weird. And then you might have even put in a whole note, which would be 800 milliseconds. And you might see a pattern here that we could manipulate, which we will right now. So let me do this. I will just do this. I'm going to delete them all. I'm going to put them in order. So we're going to start with whole note. And we're going to set it equal to 800 milliseconds, which was for our row, 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 boat, the appropriate length of a whole note. And after that, we need to make a half note, which, for those of you thinking to yourself, a half note, which was 400 milliseconds, is literally a whole note divided by 2. And so what you can do is set half equal to whole divided by 2. And there you go. That's your note length. It is literally taking a whole note and dividing it by 2 and then setting it equal to half. So half is equal to a whole divided by 2. It's that simple. You can literally do math inside of these variables. And so you could then take a quarter note, and you can do the same thing. You could either do a whole divided by 4, you could do half divided by 2. A whole divided by 4 makes sense to me. There you go. How neat is that? So an eighth note is going to be a whole divided by 8, and that should work. We start simulation. Text keeps disappearing. It should say that that's okay, except that dot quarter doesn't exist yet, so we need to do that. So dotted quarter, in this case, is actually going to be set to a quarter note times 1.5, because it is 50% longer than a quarter note. So instead of being, what was it before, 200 milliseconds, it will be 300 milliseconds. So if we hit start simulation, it should come up, and that's fine. And I can play, I think. Didn't play. Say love you. At least I can't hear it. any rate, this will still work for you. So why is that beneficial? And that's because different songs are at different time signatures. Those of you who are in band know that, or has played an instrument before, would know that each song is going to have a different time signature, and then you can just change this one number and it will set the correct pace for your song, no matter what it is. Because you've done this math, no matter what, as long as the whole note is the correct length in milliseconds, you will have set this up so that the song will play properly whatever song you choose. So you should look up soon how to make and start coding your own song. The other thing I want to show you is that you can create your own functions like this void setup and void loop. You can make your own so that you can simplify all of this code. You can actually turn this into one line here, which is what I'm going to show you to do right now. Tone is a function, and delay is a function, and no tone is a function, but they are hidden in the background. You didn't have to define them. They are automatically loaded, and the Arduino knows what they are. You could make one up that the Arduino does not know exists. And really, you just need to begin this by mimicking what this looks like. We're going to start with the word void, and the word void tells the Arduino that nothing is going to be returned at the end of this function. No value is going to be spit out here at the end. And we're going to call this, can we call this note? Let's call it note. I think we can. And what we're going to do here is we're going to put in, I think, 3 different arguments. We're going to need to put in, no, maybe just 2. We need to put in the note that is being played, the frequency, and then the length of that note as arguments. So this starts out int. You have to declare inside of these parentheses here, you have to declare your variables. These are called arguments. These are variables that are going to be put into these parentheses that will then be transferred into your function here, which is a pretty cool thing to do. So int, we need to make one called frequency maybe, and we need another one called length. That's what I'm going to do. Let's hope these are not reserved words. You need to open up a curly brackets right here, and when you hit enter, if you're on the desktop computer, it will automatically put in the curly brackets at the end, but you need curly brackets at the end. So everything in between these 2 curly brackets is your function. So our function note has these 2 things defined in it, and we are going to use them now. And so we really just want this. We're going to hit this and copy it and paste it right into our function. We're going to change some of these variables. Pin is going to stay the same because we still want it to come out of pin 12. C4, however, is going to change. We want this to be called frequency or freak here. And then our delay here will not be dot quarter, it will be length. Pin again stays the same, and our delay break thing that we did before, delay for 1 second, that's wrong. Or time. Should have been more careful when I did this before. There we go. So we have our tone through pin 12 at some hertz. Who knows? Note length turns off the tone delay for a time. Blah blah blah. So now we have this um, this function that we've just created, and we can check to see if our code worked right now just by clicking Start Simulation. And as long as no errors pop up, it's working. So that's good. So so interesting that it's not playing any sound. At any rate, what we can do now is we can delete all of this code here. Tone, all these things that we did before. We're going to make that go away. And we're going to now use our new function that we just made. So our function is called note. And we want that note to be, let's say, C4. And we want that length to be a dot quarter. We close that parentheses, and we hit our semicolon, and that's the note we've just played. Do that again. We want a C4 again, if I remember correctly. Dot quarter. Close it. Do it again. Note. C. Let's change it up. Let's do the D4 and for a quarter. Close that up. Hit your semicolon. Hit play, and ideally you would hear some sounds, but we're not right now for some reason. Who knows? So that's how you make fancy math-related variables here, and how you make your own functions. Now, interesting with Arduino. Sometimes you're going to have to put these functions before void setup in order to use them in void setup, or also then void loop. Putting them out front defines them before they get used. If you put this because you thought it would look neater after void loop, get it out of the way, it might not work. I've had programs that have gone both ways. It has worked before when it's after, and it's sometimes not worked. So it's good to have it out front just for debugging purposes. So hopefully this works for you, and this is going to make your code much, much shorter for when you start coding your own song. Hopefully it's a lot longer than row, row, row your boat. I will post a new video here shortly about how to add a button to turn it on instead of just starting right away when you hit start simulation. All right. Good luck coding.